If you like to play golf, regardless of whether you are an amateur or professional, you're probably wearing gloves to improve your swing. Let's take a closer look at the gloves that you wear. They're probably leather, or at least you think they're leather. Leather gloves are very commonly used in sports and baseball, in clothing in general, also in furniture, shoes, car interiors, phone cases. Many things you touch in life come from leather. The question, however, is what kind of leather is it? There's natural leather, which comes from the skin of cows, but there's also faux leather, which normally comes from petroleum products and polymers. And it's important to know which one's which because, of course, the price is dramatically different between which kind of leather it is. Fortunately, GERSTEL Pyro can tell you exactly which kind of leather you have in a very simple way. So what we'll do with GERSTEL Pyro to figure out which kind of leather we have, so we'll take a very small piece of leather, maybe a couple hundred micrograms, as much as a milligram, and we'll put it into a GERSTEL Pyro. We'll heat it first to modest temperatures like to 350 to get out any plasticizers if it happens to be synthetic leather. But then we'll continue to heat it over 2 or 3 minutes up to temperatures up to 1,000 degrees to make the leather decompose. If we heat it slowly this way and smart ramped, we get better performance of the pyrolysis process. Things decompose at temperatures that are optimal for that particular compound, as opposed to doing pulse pyrolysis at one temperature where everything's in the gas phase at once. They might react with each other and fall out of the gas phase. This is great news for the analytical chemist because it's minimal method development, and this avoids these secondary reactions that I just mentioned. But does this actually work? Can you tell the difference between natural leather and fake leather this way? And the answer is yes. So these are chromatograms of 2 different samples, and they're dramatically different. The chromatogram on the left from natural leather has a lot of pyrols, pyridine, in other words, nitrogen-containing compounds. There's also some sulfur compounds in there. These are indications of protein. If you get a lot of nitrogen-containing proteins, you'll end up getting nitrogen-containing compounds in the pyrogram. You get a fingerprint. This tells me right away when I see that chromatogram that this came from something with a lot of protein in it, which is almost certainly skin. So that is real leather. The other chromatogram has a bunch of chemicals in it that are not really natural. The toluene, the THF, these are all signs of decomposition of common polymers like polyethylene terephthalate or polyurethanes. So you get a really quick verification in a hurry about which kind of sample it is. If you want more explanation in detail, you want to get into the details of all these peaks, please see GERSTEL App Note 266. So remember, this is a great way to figure these kind of thing out. You get a fingerprint of what kind of material you're working with this way, with almost no method development, simple differentiation. The chromatograms are dramatically different between real leather and faux leather. It's a very highly flexible system and also allows you, that we didn't go into details today, to get polymers and additives. If you have faux leather, you can actually zero in on those polymers and additives. So is your leather real or fake? Find out using GERSTEL Pyro Core. Hope you found this information useful. Please see the other videos in this series and stay curious.